All right, so on the back, as we look at these notes, okay, so the first one, again, they're reminding us about the theorems on the front. I'd like to believe we wouldn't have forgot those already, but here we go. So we're supposed to graph the circle and then find the equation of a line tangent to the circle at that particular point. Okay, so let's go ahead and start with the slope, or excuse me, with the graph. So as you notice, right, our center for this one, okay, our center should be at 0, 0, and our radius should be 5. Right? So recall I don't have anything being added or subtracted to the x and the y, so that would be an implied 0, 0. My radius is always the root of whatever's on that other side. All right, so again, here's my center, and then the expectation when we graph by hand, right, are the verticals up and down and the horizontals left and right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here we go. All right, so our circle, now again, if they ask you to label them, right, we'd have 5, 0, you'd have 0, negative 5, negative 5, 0, and 0, 5. Okay, so if you were asked to label the points, right, we can absolutely do that. So again, something round-ish that hits the points would be great. There we go. Okay, so there's our circle. All right, then what we're supposed to do, okay, is we want the tangent line. So it's got to go through the point 3, negative 4. 1, 2, 3, 1, 2, 3, 4. Oh, it's not terrible. Okay, so again, a tangent line is going to hit exactly once, and it's going to go, sorry, I lost my ruler. Maybe. All right, here we go. Sorry, here's the ruler. All right, so here's my line, give or take. All right, so you might recall that in order to write the equation of a line, right, the equation of a line, I'm going to need at least a point and I'm going to need a slope. Okay, needs the slope. All right, we're not going to do it from our graph, right, because again, my graph is not accurate. It's just to give me an idea of what I'm looking for. So instead, what we're going to recall, okay, is that from the radius to the point of tangency, we know that it hits at a right angle. Right? This is what I know, that there is a right angle created there. So if I could find the slope of the radius, right, then I could use my properties of perpendicular to be able to figure out the rest of it. So we're going to do slope of the radius, because that I do have two values for, right? I know my center and I know my point of tangency, so I can go ahead and find that. So again, slope is going to be change in y, so negative 4 minus 0 over 3 minus 0. So the slope of my radius is going to be negative 4/3. My tangent line hits at a perpendicular, okay, which means that my perpendicular slope, right, we flip it, so 3 over 4, instead of negative, it's going to be positive. Okay, so now I've got a slope and I've got a point. So again, I think the easiest thing to do is point-slope form. Okay, not that, again, you can plug it into y equals mx plus b and solve for b, but I think point slope is a little bit easier. So y minus the y value is equal to my slope, and again, I want to use my new one, right? I want to use the one of the line, okay, x minus the x value. So y plus 4 is equal to 3/4 x minus the 3. If we distribute, right, so y plus 4 is going to be equal to 3/4 x minus 9/4, excuse me. All right, to get this by itself, I'm going to go ahead and subtract 4 on both sides. So y is going to be equal to 3/4 x, and then 9/4, if we punch that. Okay, so again, on your calculators, just to remember, right, if we take negative 4 divided by 9, I'm sorry, other way. I typed it correctly, but said it backwards. Negative 9/4, and then we're going to get rid of 4, change it to a fraction, and there's your negative 25/4. All right, so this would be the line that is tangent. So my blue line, my line that's tangent to the circle, okay, which means my slope is perpendicular at that particular point. All right, so let's go ahead. We're going to look at the second one. Same idea. We're going to try it again. So graph the circle and then find the equation of a line tangent at the point 3, negative 4. Okay, so same idea. This time, if we're going to notice, right, our center of the circle is going to be at negative 1, negative 2. Okay, and our radius, not so nice this time, square root of 20, right, which is about, right, if we take the square root of 20, That's about a 4.5. Right, so just for the sake of graphing. All right, so my center, -1, -2 would be right about here. Okay, and we're going to go out about 4.5. 1, 2, 3, 4, so ish. 1, 2, 3, 4 ish. 1, 2, 3, 4 ish. 2, 3, 4 ish. All right, so give or take, there's my circle. All right, so again, something round-ish that goes through those points. The idea is we just want to get an idea of what we're even looking for. All right, so it's supposed to go through 3, -4, 3, 1, 2, 3. Oh, that's, again, not terrible. You've seen my drawings in class, so you know they're not fantastic. All right, so here we go. There's our line. All right, so what we're looking for, right? So remember that where the radius hits the point of tangency, a right angle is created. All right, so step 1, we're going to need the slope of the radius. All right, so remember that's change in y. So again, here's my center, and that's my point of tangency. So if I start with my center, I would have -2 minus -4 over -1 minus 3. Negative, negative, that's really positive. So -2 plus 4 would put me at a 2 over -4. And so if I reduce that, I've got a -1/2. Now, that's my radius. But what I want is the line, right? So the line that hits it, it's got to be perpendicular. So my perpendicular slope, I flip it, right? If this one's negative, this one's positive, right? So my new slope is really going to be a 2. So once I have my 2, again, here's my point. So now I have a point, I have a slope, and so I'm going to use point slope form. All right, so y minus -4 is equal to slope x minus the x coordinate. So y plus 4 is going to be equal to a 2, x minus a 3. Distribute, so y plus 4 equal to a 2x minus 6. And then if we go ahead and move that 4, y is going to be equal to a 2x minus 10. Now, again, they did not say, like I should note that as we're doing this, it never said that it had to be in slope-intercept form. Pre-AP is, again, if I'm betting, pre-AP is going to want it in slope-intercept form. OST is very generous on their answers. So for us, again, it will say slope-intercept form, just so that we're all on the same page about that. All right, I'm going to scoot it down just a little bit. You have the pleasure. You can always pause if you need a little more time to copy. All right, so here's our next one. Find the equation of the line tangent to the circle, blah, 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 at that particular point. Okay, so our first step is, right, we've got to find, we know that we're going to need a radius, right? So even if I don't graph this, I've got to know the center, right, so that I can figure out the slope of my radius. So I have a point, but let's go ahead and mess with this for a second. So let's put our x's together and see if we can get it to look like, okay, the equation of a circle. So I've got x squared minus 6x. Now again, I'm just going to go ahead and put a box in here, right? And then I've got a y squared, nothing else with my y, and I'm going to go ahead and move that 1 to the other side. Okay, so what I'm noticing, the y squared is done, right? It's just going to have that 0 with it, but I need to complete the square for the front one. So -6 cut in half squared, right, would give me a -3 squared. And so that's going to go in the box here. Now remember, right, I should have added my box over here, right, that whatever goes on the left side also has to go on the right side. So I've got a 9 over here as well. So the equation of my circle, if I go ahead and write that, I would have x minus 3 quantity squared plus y squared, and that's going to be equal to a 10. All right, which means, right, my center, which is the part I need, my center is going to be at 3, 0. Okay, and I don't really care about the radius. Okay, so once we have that, right, our next step is we've got to find the slope, right? So I need the slope of my radius. And my radius should go from the center to the point of tangency. Those are the two that we're going to use. So again, change in y over change in x. So -1 minus 0, right? -1, 0 over 0 minus 3. So I'm going to get a -1 over -3. So there's my 1/3. but that's the radius, right? So remembering that's my radius. I need the tangent line, so I need my perpendicular slope, which would be 3. Sorry, I kind of curled that, like 3 over 1. If this is positive, this one's negative. Okay, so I would have negative 3. That's going to be my new slope. All right, so now I've got a point, right? That's my point of tangency. That's going to be my slope. And so when we plug it in, right, I would have y minus the y value equal to my slope, x minus the x value. So y plus 1 is going to be equal to negative 3x. And then if we move that 1 over, sorry, I'm running out of room, y is going to be equal to negative 3x. Again, I would subtract the 1 on both sides. And there's my equation for the line of tangency. Line of tangent line. Sorry, tangent line. That's what I want. Okay, number 6. So they can, again, we could ask it the same way, right? Same idea, but we can just, you know, a couple different, just some slightly different variation on the wording. So now we've got an equation of a circle. I think they forgot that part. An equation of a circle. That's that. With the center at 2, 3, radius of 1. Find the tangent line to the circle that goes through that particular point. Well, all I need from the equation of the circle is the center, right? I don't, like the last time I didn't have one, so I had to actually go through and find it, but this time I have it. So again, my first step, I just need the slope of my radius. All right, so slope of radius. Again, my radius is going to extend from my center to the point of tangency. So I'm going to go ahead and subtract, right? I've got 3 minus 3 over 2 minus 1. So I'm going to get 0 over 1, which is really just a 0. So we're going to think, right, when I have a slope of 0, right, this really means, remember, these are y's over x's. I haven't had any change in my y. Okay, if I haven't had any change in my y, that means my line has not gone up or down. It just extends left or right. So this is a horizontal line, right? That would be horizontal. So when I want to look perpendicular, right, my slope would be undefined, right? If I had 0 over 1, the 0 is on top. If I flip it and put a 0 on the bottom, I'm not allowed to divide by that. Okay, so this would be a vertical line. Okay, so we're going to think for just a minute. If I want a vertical line, right, so if we kind of sketch out a picture here, I don't really care where it is, but my point is if I want a vertical line, it crosses the x-axis. So if it crosses the x-axis, that means a vertical line is x equals some number. That's vertical. So if I look back over here, right, it's got to go through the point 1, 3. Okay, well, of that coordinate, the x position is filled with the number 1. So my line that's going to touch my circle and be vertical would be the line x equals 1. Okay. All right, and then our last one. All right, so number 7. We've got an equation, again, we forgot those words. You have an equation, again, of a circle. With a center here, radius 5, which we don't really care. Find the tangent line to the circle that passes through the point 2, negative 3. Okay, so once again, right, they didn't ask me for the equation of a circle. We could certainly write it, right? If I wanted to write the equation of a circle, right, I would have x minus 5, and then we would have a y plus 7, and then we would take our radius and we would square it. So if I really wanted to write the equation of a circle, I could. But again, excuse me, I don't need to for this, because what we want is the tangent line. So again, we need the slope of the radius. So again, my radius is going to go from the center to the point of tangency. So change in y, negative 7 minus negative 3 over 5 minus 2. Okay, so I'm going to end up with a negative 4 over 3. That's my radius. Which means that the tangent line, which is perpendicular, I'm going to take my slope and I'm going to flip it. So I'm going to have 3 over 4. If this one was negative, this is positive. All right, and then we're going to plug it into our equation, right? So I've got a slope, I have a point, so we're going to go in point-slope form. So y minus the y value is equal to my slope, x minus the x value. So y plus 3 equal to 3/4 x, and then again I could distribute that. So if I take it through, I'd have minus 6/4, which, yes, I appreciate that can reduce. We'll get that next, right? So I'm going to go ahead and move that 3. And so y would be equal to 3/4 x. Now again, on the calculators, just in case we don't remember, I would go ahead, I've got 6/4, sorry. Oh, and that should be negative. So I'm going to second insert, let's insert a negative sign. So negative 6/4, we're going to subtract 3 from that. Again, you could leave it, but I'll change it back to a fraction. So negative 9/2. So in slope-intercept form, that's going to be my line, my tangent line.